Hey, welcome back, 8th grade. So now we're going to move into a property when it comes to multiplying exponents. Well, multiplying powers. All right, so we have what's called the product property. Basically what that is if I have a power, or two powers I should say, being multiplied together, if they have the same base, notice here we both have a's that are not 0, so a cannot equal 0. Then that is going to be equal to a plus n to the m plus n. And then like if you want to know why that works, if we did a cubed times a squared, we would have 3a's times 2a's, which gives us a to the 5th, which is the same. If we would have done 3 plus 2, we would have gotten a to the 5th power. So that's why it works. That's the rule. If we're multiplying same base, we add. So let's do some practice. Do not multiply the bases here. If it is the base, it stays the same. Base stays. And then we're going to take our exponents and add them together. So our final answer here is 12 to the 7th power. So again, base stays. So we're going to have negative 5. And then we're going to add negative 2 plus 7. Don't go changing this negative 2 as a fraction. It really is easier to just add everything that we can at that time. Saves us some trouble with flipping and then having to flip back. All right, negative 2 plus 7. We got to keep that negative 5. Negative 2 plus 7 is 5. So our final answer is negative 5 to the 5th power. Moving on to example 2, we get just a little tad bit more difficult, but really coefficients, as long as they don't have an exponent, we're just going to multiply them together. So we're going to do 4 times 9. Now our z's are our powers here, so we're going to have z to the, and then we're going to do 5 plus negative 12. So 4 times 9 is 36, and then we're going to have z, and then 5 plus a negative 12 is negative 7. Now we're not done. This is still a negative exponent. We can't leave negative exponents. So we're going to do 36 over, because right now it's in the top, right? So we move it to the bottom. Only the one with the exponent, which is the z. The 36 stays in the top and the z moves to the denominator and becomes positive. Silly Miss Cartwright. So we have 36 over z to the 7th power. So same thing here. I'm going to take 2 times 9 times 3, and then a. Now, the difference here is this a doesn't have an exponent, but it has the invisible 1 for its exponent. Because if it was a 0, it would equal 1. Since it's an a there, there has to be at least one a. So we have 1 plus 4 plus 2. So then 2 times 3 is 6. 6 times 9 is 72. And then a to the 1 plus 4 is 5, plus 2 is 7. 72a to the 7th. And those are our answers for example 2. So now moving on to example 3. At 20 degrees Celsius, 1 cubic meter of water has a mass of this many grams. Each gram of water contains about this many molecules of water. How many molecules of water does the droplet of water shown below? Well, and it says below. Mrs. Cartwright didn't attach the picture. So this is what the picture looks like. Circle, and that the volume is 1.13 times 10 to the negative 7 meters cubed. All right, so this is saying that cubic meter of water has a mass of about, so I can change my cubic meter of water to grams. So I'm going to take my 1.13 times 10 to the negative 7th. I'm going to take that times my 9.98 times 10 to the 5th. So that gets my cubic meters into grams, because cubic meter would equal 1 gram over 1, or however many grams over the cubic meters is what we set up. All right, And so the cubic meters have now gone away. But now I need my grams to change into molecules, and I know that each gram contains this many molecules. So I'm going to then take the fact that I'm going to call it a mole to my grams, and my grams will cancel out, which ends up being multiply, multiply, multiply. So I'm now going to multiply my 3.34 times 10 to the 22nd. So just like with our last problem, we're going to multiply the numbers together. So we're going to take 1.13 times 9.98 times 3.34, then we're going to do times 10 to the, and then they're multiplying, so we're going to add the exponents, -7 plus 5 plus 22. All right, from here I'm going to multiply 1.13 times 9.98 times 3.34 is approximately 37.7, and then we're going to have times 10. -7 plus 5 is -2 plus 20 plus 22 is 20. So this is what we have so far. Now the thing is with scientific notation, our number has to be single digit number, which means I can't keep this as 37. I need to move my decimal over and make this approximately 3.77 times 10. And because we moved it to the left, we actually add 1 because that's one extra move we have to make to the right. So now we're 10 to the 21st power. And so what does that mean? The droplet, this little droplet here, contains about 3.77 times 10 to the 21 molecules of water. I don't know if you can comprehend that. That means 19 zeros after that 7. That's how many molecules of water are in that droplet. All right, but that's why we use scientific notation. That itself, using scientific notation in science and engineering, etc., is really, really helpful. That is where exponent rules come in play the most. Until next time, 8th grade, I will see you for our next video on rational exponents.